so that we know how to simplify. If there is a bigger type of root. So we're going to start off with the third root. So we're going to do 2 times the third root of 48. So just like we did with the square roots, we're going to do the little factor trees. But we're going to have to be careful since today we're going to deal with radicals that aren't just square roots. So if we do our little factor tree, what times what is 48? 12 and 4. So I heard other options. You can do whichever options you want, but 12 and 4 was what I heard first. All right, how do we break those down? Okay, 6 and 2. And then 2 and 2. And then that is 3 and 2. Okay, now if you're doing square roots, you look for pairs. If you're doing square roots, you look for pairs. If you're doing cube roots, you look for triples. So I've got a triple of 2's, and then I've got a leftover 2 and a leftover 3. So since I've got a triple of 2's, what am I going to do with that triple? What do I do with the triple? You put it in, does it go in the front or underneath? In the front. So I already had a 2 in the front. I'm going to add these 2's in the front as well. And then I've got a third root, and what is left underneath? Six. Yeah, 2 times 3 is 6. So my final answer is going to be 2 times 2 is 4. 4 cube root 6. And we changed how the problem looked, but we didn't change like numerically what it represents. So if I want to double check this, I could say 2. To get the cube root, I hit the math button. Underneath the green button, there's a math button. Cube root is the 4th option. So 2 cube root 48 is the same as 4 cube root 6. Same number, just looks different, simpler. All right, let's try another one. This one's going to be 3 times the cube root of 108. So what times what is 108? What times what is 108? Wow, you guys are good at multiplication. I was going to do 2 times whatever it is when you divide it by 2. I just go like, it's an even number. Let me divide it by 2. Is it 9 and 12? Should I believe you guys? 9 times 12. Wow, why are you guys good at that? Okay. And then how do I break these down? 3 and 3. Okay, 3 and 3 and 4 and 3. Okay, and then the 4 is going to be 2 and 2. Okay, so we have a triple of 3's and a pair of 2's, but the pair doesn't mean anything to me this time because I'm doing a cube root, not a square root. So I don't care about pairs, but I do care about triples. All right, so what should I do? So take the 3, put it on the outside with the other 3. And then I've got cube root of what? 4. So my answer is 9 cube root 4. Because the original problem had a 3 in the front. And I have a triple. And so I'm taking the 3 in the front and the 3 that I got. And I'm putting that in the front. And I'm multiplying them together to get 9. Okay. Let's try the cube root of negative 250.
Oh, wait, so like you keep like what is the experiment? Then you just multiply it. And like what? So it makes no sense.
What part are you talking about?
The first part of the like radical, like 3 times 3, and then you have 3 left and 4.
So this 3 is the cube root. So I'm going to have to keep a cube root. I'm going to have to keep the 3 in there to say what type of radical it is. So this 3 is never going to change. I'm just always going to have that. This 3 is a coefficient just sitting in front of the problem. Like 3x, whatever. It's just a number sitting in the front. And then this, since I had a triple, this number needs to move to the front of the radical as well. So it moves to the front of the radical with the other number that was already in front of the radical. Are we about to use what for this one? No. Why is this one not going to have an I? It's because it's got the 3. So when you have a cube root, it's okay to have a negative because, why are we on our phones? Shelby, go ahead and put your phone in here. All right. A cube root can have a negative because a cube root is just saying what multiplied by itself 3 times becomes that number, and negatives will do that easily. So a negative times a negative times a negative is a negative. So you can cube root a negative number and your calculator will not protest it. Like if I were to cube root negative 8, my calculator's like, oh yeah, that's negative 2. Because negative 2 multiplied by itself 3 times gets you negative 8. If I wanted to cube root negative 1, that's not an issue because negative 1 multiplied by itself 3 times is still a negative. It's only an issue if you do it with a square root. That's going to be an issue. If we do it with a 4th root, that's going to be an issue. So our even number roots can't have negatives, but our odd number roots can. So that's what we just have to watch out for. So having the negative inside here, all that means is that our answer is going to be negative. Like we can just take the negative and move it to the front. That's all we need to do. So I'm going to ignore the negative for now. I'm going to deal with the 250. So what times what is 250? So we can do 25, 10. We can do 5 and 50. What do you guys want to do? 25 and 10. Okay. 25 and 10. And then how should we break these down? 5 and 5. 5 and 2. Okay. So we have a triple with the 5s and a leftover 2. So I'm going to take the 5, move it to the front. I'm going to do the cube root. I've got the 2. And then I had a negative inside. I just know that that means that my answer is negative, so I'm going to move the negative to the front.
So it's not going to be on the inside?
You could leave it on the inside, but typically if you've simplified something, you would just move it to the front. Yeah. So it just means that that it was a negative number times a negative number times a negative number that made you get negative 250. Yeah. Okay. Do we feel comfortable with how we did those? Yes? Okay. Let's try something to the 4th power, or a 4th root. So we're going to do 3, and then we're going to do 4th root of 162. Yeah. So if they don't, then it just means that it can't be simplified and you just put everything back underneath the square root. So if you're doing, it just kind of depends what you're looking for. If it's a 3rd root, you're going to look for triples. But now we're going to do a 4th root example. So instead of looking for triples, we're going to look for quadruples. Yeah. So you're always just looking for whatever matches the root. And if it doesn't have them, then you just say, oh, that one couldn't be simplified. Like if we were square rooting the number 17, that's a prime number. You can't break that down. So if you tried, you wouldn't find any pairs, and then you would just go, oh, it must have been simplified to begin with. Yeah. So it's possible that you wouldn't find what you were looking for. That's always possible. Yeah. Okay, let's break down 162. 81 and 2. 81 and 2. Okay. Break down to 81. What do we get? 9 and 9. Okay. Break down the 9s. What do we get? 3 and 3. 3 and 3. Okay. So since it's a 4th root, we're looking for quadruples. So I have a quadruple of 3s and a leftover 2. So I already had a 3 in the front. My quadruple of 3s means that I'm going to put another 3 in the front with that 3. And then I still have a 4th root. And the leftover 2 goes inside. So my final answer is 9 times the 4th root of 2. And if you want to type this in so that you can check your answer, we're going to type, I think this is how, I'm going to double check it. I think this is how you would type it. To do a 4th root, you have to do 4 and then hit the math button right underneath the green button and then do the number 5. So you have to tell the calculator what root you're doing first. So I think if we want to do a coefficient times the 4th root, I'm guessing we're going to do 3 times and then hit the 4. Yeah. Okay, so 3 times 4. 4th root of 162 is that decimal. And then if we want to do 9 times the 4th root of 2, same decimal. So we know that we got a simplified version. Okay. Comfortable? We're good? Okay, can I start adding some variables in here? Sure, variables are fun. Okay, let's try some of those. Okay. So we'll do let's do 3rd root 216 m to the 3rd n to the 6th. 3rd root of 216 m to the 3rd n to the 6th. Okay. So 216. What do we do? Do the tree. So what multiplies to 216?
2 and 108. Or that.
You said 3 and 72. Okay. And then how could we go from there? 8 and 9. Is that what you said? 8 and 9. Okay. And then what do we do? 4 and 2, 3 and 3. So we have a triple of 2s and a triple of 3s, and we have no leftovers. Do you guys remember what it means if, like, when we were doing the square roots, if it only had pairs and no leftovers? In this case, if it only has triples and no leftovers, what does that mean?
And it's a perfect square.
It was, so in this case, it was a perfect cube. It was a perfect cube. What is 3 times 2? 6. So this is a perfect cube, and that means that the cube root of 216 is 6. That's what that means. So we can double check that by just seeing what 6 to the third is. 6 to the third is 216. So that happens to be a perfect cube number. If you end up only getting triples, that means that's what you found. Okay, so we know the answer is 6. We're not going to have any leftovers to put underneath the cube root. Let's look at the letters. I'm going to write out M 3 times, and then N 6 times. Okay, and then what am I circling? What am I circling? Triples. So I've got a triple of M's and 2 triples of N's. Okay, so we said this was 6. We did 3 times 2. And then what should I write for this? M. And what should I write for this? N squared. So this whole thing was a perfect cube. And when you cube rooted it, you were able to cube root it evenly and not have any leftovers underneath the cube root because it was a perfect cube.
So that'd be the
That's the answer. Because every single piece was cube rootable. Okay, let's try another one. We're going to do the cube root of 56 r to the 8 s to the 4. Okay. Not a perfect cube this time, so it'll be more interesting.
Is that SR or is this S4?
S4. Yeah.
It wouldn't come out.
All right. What do I do with the 56? 8 and 7. Okay. 4 and 2. And then 2 and 2. Yeah, and then the R's, we have 1, 2, 3, 4, 5, 6, 7, 8. Oh, I could circle my triples over here too. Got a triple and a leftover. Okay. And then 1, 2, 3, 4. Triple and a leftover. Okay. So if I look at all of my triples, what should I have out in the front? 2.
R squared.
R squared. S. Okay. And then cube root. What's left over underneath the cube root? 7 r squared s. 7 r squared s. So the triples go in the front. 2 r squared s. And the singletons go underneath. 7 r squared s. Okay, let's try. Okay. Negative 64 cube root, negative 64 x to the 10th, y to the 25th. Yeah, we're going to put a negative in front of our answer. And then it's 8 and 8. Four and 2. 4 and 2. 2 and 2. 2 and 2. So got a triple and a triple. So what does that mean? Perfect cube. So what is the cube root of 64? 4. The cube root of 64 is 2 times 2, which is 4. Okay? So we got our x's. We got 10 of them. I mean, if you got a better way to do it, tell me what it is. Okay. So okay, so if we thought about the y's, we know that there's 25 of them. We have to divide it by 3. Okay, so with the y's, how many sets of 3 are we going to have? 8. Okay, 8 sets, or 8 triples. Okay. 8 triples. Is 8 triples all we have? You have 1 left over. Okay, and then 1 singleton. Okay. Okay. Yeah, so if you don't want to write them all out because you can like mentally think it through, that's fine. Okay. All right, so let's write what we have now. So we have a negative in the front. Okay, and then what do we have with our numbers? 4. 2 times 2 is 4. Okay, what do we have with our x's? X cubed, x to the third, so x times x times x. What do we have with the y's? Y to the 8, because we had 8 triples. Okay, so that takes care of the outside. Now we're going to do the inside. What is there any number that belongs inside? No, there was no singletons left over. The 4 we broke down, so we're not using that. Okay. Any leftover x's? Yeah, just 1, right? And then how many leftover y's? Just 1. Okay. How do we feel? Pretty easy? Okay. All right. Do you guys want to do any more of those, or do you feel like you're ready to like practice? Ready to practice? Okay. I have a worksheet for you guys, so I'm going to let you guys work on this worksheet. We're going to start with, well, the first 4 are just calculator problems. I'm going to let you plug those in your calculator. And then after that, you're going to start simplifying. So start at the beginning, and we'll see how far we go, and then I'll tell you guys what the homework is. At the very top, when you guys get this page, you're going to label this 2.2 homework is what you're going to label this, okay? 2.2 homework is what you're going to label it. And then I will tell you before we leave which problems are going to be considered 2.2 homework, okay? Before we leave, I'll tell you which ones. Okay.